Hello, welcome back to my channel. So today I'm going to discuss problem number 2 of the 2025 A-Level Physics MCQ paper. Again, a disclaimer, I don't have the English examination paper with me. So I'm translating from the Sinhala paper uh, to English. That's what I'm doing. So let's get to the problem. Okay, let's read problem number 2. A student using a stopwatch measures a time of 20 seconds for 10 oscillations of a simple pendulum. If the least count of the stopwatch is zero point 0.1 seconds, what is the percentage error in the measured time period of the pendulum? So I'm going to give you a detailed analysis how to solve this problem. First, you have to understand that there are two things in this problem. There's a stopwatch that measures the time, and then there's the simple pendulum. So let's write down things related to the simple pendulum. Let's define the time period of the simple pendulum as capital T, uppercase T. So that's the time period. Time period of the pendulum. And then there's another information about the pendulum, the number of oscillations. Let's say capital N is the number of oscillations of the pendulum. And now let's look at the stopwatch. Let's define lowercase t or simple t as the time measured by the stopwatch. Time measured by the stopwatch. And then we have the least count of the stopwatch. So this is what we call the error of that time, the stopwatch. So that is written as delta t, error, error in t, or basically the least count. Least count of the stopwatch. And we know that value that is given in the problem, delta t is equal to 0.1 seconds. So you can clearly identify there are two things in this problem. The time period of the simple pendulum and related error for that, and the measured time of the stopwatch and related error for that. If you look at the question, it's asking percentage error in the measured time period of the pendulum. It's not asking for the percentage error of the time measured by the stopwatch. It's asking for the percentage error in the time period of the pendulum. So that means we need to come up with a relationship between capital T and simple t, because the information is mainly given for simple t. So what is the relationship between the time period of the pendulum and the measured time of the stopwatch? So it's very clear that time period of the simple pendulum, capital T, is equal to time measured by the stopwatch, simple t, divided by the number of oscillations of the pendulum. Okay, so that's the relationship that connects the two variables. Now, since the error in the stopwatch is given as delta t, we need to figure out what is the error in the time period of the simple pendulum. So using error propagation, this is a simple relationship. We can clearly find that delta simple t divided by n is equal to delta capital T. So that's how the errors in the two variables connect to one another. And I'm going to call this number 1 and keep it over here. Now I'm going to define what the percentage error is. Some of you might not remember from your classes what percentage error is. So I'm going to define that. So percentage error of a measurement is given as the fractional error of that measurement. Okay, fractional error of that measurement multiplied by 100%. Multiplied by 100%. What is fractional error? Fractional error simply is error over the measurement, or in this example, we can say the least count. Least count over the measurement. And then we have to multiply that by 100%. Okay, so that's the percentage error. So this is something important that we are going to use in this analysis. So we need the percentage error of the time period of the pendulum. So least count, or the error of the time period of the pendulum, delta t, divided by the measurement, that is the time period, uh, T, uppercase T or capital T, times 100%. So that's what we need to find out. But you can see we don't know delta T. We cannot calculate delta T with the given information. So for delta T, I'm going to substitute 1, that is delta lowercase t. So delta T divided by n, and then again divided by the time period of the simple pendulum. So this is from 1. Okay, and then we have to multiply this by 100%. But what is n times t? Look at the denominator, number of oscillations times the time period. So that's the time measured by the stopwatch. So delta lowercase t divided by lowercase t times 100%. So what you can see is that percentage error of the time period of the simple pendulum is equal to the percentage error of the time measured by the stopwatch. So for this example, that's what you need to know. Delta capital T over capital T times 100% is actually equal to delta simple t divided by simple t times 100%. Okay, so that's an important derivation for this particular problem. And now we have enough information to substitute. Delta t, the least count of the stopwatch, is 0.1 divided by the time measured by the stopwatch, that is 20 seconds, multiplied by 100%. And then when you solve this, you can see zero point 0.1 divided by 20, that is 1 over 200 as a fraction, multiplied by 100, then you get 1 half, 0.5%. So the answer is 0.5%. That's the percentage error of the time period of the pendulum. So the correct choice is choice number 3. Choice number 3 is the correct choice for problem number 2. So that's how you do this problem. Thank you.